Hello, we are here for one more lesson of this T-FLEX analysis training course, and the topic for today, still inside thermal analysis, it is thermal analysis steps. So this specific analysis is performed also in several stages. The sequence of these steps are very similar to the other study modules of T-FLEX analysis, so we will go through them. We may skip certain details because we've talked already about them in other studies, and the concept it is the same. So as usual, the first step it is to create a study. So inside the analysis menu, new study, and then we go to the group of thermal analysis. We can choose from these two, the stationary thermal and the non-stationary thermal analysis. We've seen already that the difference between them it is the properties and the loads, the whatever we may define, do not vary in time in the first one and varies in time in the second one. After this, we will need to create a mesh. You know that already. It's the basis for finite element software. We always need to have a mesh. And then we will apply boundary conditions, which it is common also to all of these studies. The boundary conditions for a thermal study are a little different from the other ones. Okay. In this thermal analysis, the boundary conditions are represented by the boundary and initial temperature. So we have a specific menu to insert these conditions. And as you can see, we have temperature, heat flow, convection, heat power, radiation, thermal contact. These boundary conditions are represented by the boundary and initial temperatures, heat power sources, heat flux, and conditions of heat exchange between the model and the environment. These particular ones are convection and the radiation. When we define thermal loads, let us say one of it, or let us assume, for example, temperature. We need to distinguish and appropriately use two options to define the temperature load. We have the possibility to define it as initial temperature or simply as temperature. Initial temperature, it is used to define the thermal loads at the beginning, the initial moment in time, and all thermal loads defined without the initial flag are considered constant in both of the modules, stationary and non-stationary. Okay. Then we move to solve. We can adjust the algorithms in these specific tabs. So a big part of this we already spoke about them. So we can define also, if it is a non-stationary, the time to study the phenomenon and the increment and the equilibrium, if it is the thermodynamic equilibrium, if it is if it exists or not. Finally, the results that we may have from this study are temperature fields, which you can define as a temperature distribution over the model's volume. Thermal gradients by the three axes, x, y, and z, and the magnitude of those thermal gradients. These, what we call the thermal gradients, reflect the degree of temperature changes by each one of the axes of the coordinate system. We can have also the resulting thermal flux by also each one of the axes and the magnitude of this thermal flux. This specifically shows the rate of thermal energy transfer, which is determined from the solution. We have also something called the prescribed thermal flux. These correspond to the specific initial temperatures of thermal loads. We have the prescribed temperature. Definition, it is the constant thermal loads applied to the model. And finally, the initial temperature, which it is the initial temperature applied to the model for the transition thermal analysis. I think this explains a big part of what we have in terms of steps. Again, the non-stationary thermal process results much more data than the stationary. So we can manage this time and the steps, and it will help a lot to define the time and the resources needed to have a result. But in terms of experience, if you make a couple of examples, for sure you will understand what you need to have in all the parameters. Again, about this thermal analysis, we have a lot of videos showing examples. You may consult them because I think they are a good source of information to help you start under this topic. As we say always or I would say in the majority of the videos, any help, any support that you may need about this, let us know, and we will answer your questions and give you all the necessary support.